Before we get into our new notes, let's work on these warm-ups. So our warm-ups were to find the slope. We were given points on number 1, -3, 8, and -2, -5. How do we find the slope between 2 points? Okay, y2 minus y1 over x2 minus x1. So what do you want to plug in for y2? -5, good. We're doing the first warm-up problem, which I had written off to the side, but I wrote the points up here. We're finding the slope between these 2 points in the warm-up. Okay, so our y2 is -5, then we subtract our y1, 8, divided by, what's my x2? -2 minus -3. We have questions? Okay, James said, does not make it plus. Yes, subtracting a negative means this turns into being a plus 3.
-1. I mean positive 1.
The denominator would be a positive 1. The numerator is -13. You could leave it as -13 over 1. That would be just fine. Okay, number 2. Our points were 6, -8, and 10, -8. So when we find our slope, what do you want to plug in for y2? -8 minus -8. On the denominator, 10 minus 6.
0.
My numerator is 0 over
4.
4. It doesn't really matter what it's over, though, because 0 over anything is...
0.
Undefined.
0.
Undefined.
0.
Undefined.
Ladies. Questions about our warm-ups? Okay, 0 can be on top, 0 cannot be on bottom. So if 0 is on the bottom, that is when it is undefined. There you go. N-O, no, when it's on the bottom. Back to today's notes. We are starting chapter 4. We are going to start off with writing equations in slope-intercept form. Now, we have done this before when we've been given equations that were not in slope-intercept form, and we've changed them to be in slope-intercept form. But today we're going to be given other information so that we can come up with the equation all on our own. Anybody need more time with their objective? Okay. Slope is the rate of change of a function. Should be following along to fill in our blanks. The rate of change. We can calculate slope using any 2 points on the line. Of course, we should be familiar with that slope formula, y2 minus y1 over x2 minus x1. Okay, those next two are a little small to see, so I'll write them bigger. 1 point is x1 comma y1. The other is x2 comma y2. This is the idea we used in our warm-ups to find the slope of the line between the points. All right, when we write equations in slope-intercept form, again, slope-intercept form is a review. It's y equals mx plus b, where m is the slope and b is the y-intercept. Of course, we should know that the y-intercept means that that is where the graph crosses the y-axis. So if we were to have some axes drawn in here, and we draw in a line on those axes, but at the point where we cross the y axis, that is our y-intercept. Okay, so today's goal is going to be to write equations that are in the form y equals mx plus b. When we do that, we're going to leave x and y as x and y, but we are going to replace m and b with numbers. So we want to replace m and b with numbers. That's our whole goal. Y and x will stay the same. M and b will become numbers, whatever they are for that situation. Questions, concerns? Dominic?
For the slope formula, can an easier way to remember is like right 2 and right and left 2 and then right 1 and left 1.
So that's fine for graphing, but when we're just given points, given numbers, we have to be able to use that formula. Okay? All right. The first couple examples are pretty easy. We are writing the equation of each line given the slope and the y-intercept. This is the easiest possible situation. So again, slope-intercept form in general is y equals what? mx plus b. And our goal is to replace which two letters with numbers? M and b. We're trying to replace m with a number, and we're trying to replace b with a number. They gave us a slope. What letter do we use for slope? M. So they gave us m. And then the y-intercept they gave us, what letter is that? B. So they gave us the numbers that we need to do this. All we have to do is start writing y equals, instead of writing an m, what do you think I'm going to write? 3x plus, instead of a b, -1. Now to make this look a little bit nicer, instead of writing add a negative, what could I write? Just subtract a positive, just of 1. So this is how I would want that answer to be written. Y equals 3x minus 1. Now, unfortunately, not every single problem we do will be quite this simple, but they're starting us off pretty easy. So again, slope is which letter? Y-intercept is B. So when I rewrite this, y equals 1/2 x plus 0. Do we need to write a plus 0? No. So the way we should write it is just y equals 1/2 x. If you write the 0, I will not take off points for it. But you won't see the 0 written in the textbook if that's what the answer is supposed to be. Now, if you put the 0 by the x instead, then I would take off for it. Questions, concerns on this slide? Okay, moving on. Still working with y equals mx plus b. Anybody know what letter C is going to look like? Okay, so if we do it literally and plug in our m, that's my slope, and plug in our b, my y-intercept, this is what it would look like. Or, nope, sorry, not a B, a 5. There we go. However, 0 times anything is just 0, so really our answer should be y equals 5. Okay, again, I probably wouldn't take off points if you left the 0x in there, but really you should know that a line that has a slope of 0 is a horizontal line, so it should be a y equals a number line. On letter D, we've got a slope of negative 3/4, so that's my M. A y-intercept of 8, that's my B. So what will this equation look like? Good. Y equals negative 3/4 x plus 8. Nothing to simplify about that. We can just leave it alone. All right, now they're making it a little more interesting on us. They're not just telling us our M and our B, but they're giving us a graph. So we are going to have to figure out M and B so that we can write our equation. So I'll still write the general form up at the top. So I need to know what M equals and what B equals in order to write my equation. Okay, slope, we could use our formula, but since they gave us a graph, how else could we find slope? What 2 words do we use to talk about that? Rise over run, very good. We could use our rise over run to figure out our slope. So if we start over here on the left side, how many am I rising to get level with that other point? 6, good. So our rise is a positive 6 since we went up. How far did we run over? 4. Positive 4 since we went to the right. But we should simplify that. 6 over 4 simplifies to be 3 over 2. So we have our M. Yes. Fractions should always be simplified, especially for slope. The next thing we have to identify is our B or our y-intercept. Has anybody found it? Good. Why is it negative 3? Beautiful. This is our y-intercept because it is on the y-axis. So they actually did give us that point. When x is 0, that number is our y-intercept. So B is negative 3. Questions about how we came to that conclusion? Okay. Now we have all the information we need. So has anybody used it to write an equation yet? Very good. Y equals 3/2 x. Normally we would say plus a negative 3, but instead we would just write it as minus 3. I want you to try that second one on your own for a couple minutes. So identify your M and your B, and then use those to write your equation. What did we get as our slope?
Negative 3 over.
Okay, I don't really mind where you put the negative. You can write it top, bottom, or out in front. Negative 3 over 4. Our B or our y-intercept is 2. Okay, so for your slope, remember to do rise over run. So I would agree with a negative 3 over 4 because we went down and then right. So negative and positive.
Y equals negative 3/4 x plus 2.
Good, that makes our equation y equals negative 3/4 x plus 2. One thing that can be a helpful check for yourself as you're doing this is to look at the line that they give you. On the first one that we did, our line was going uphill, so it made sense that our slope was positive. On the second one, our line was going downhill, so it made sense our slope was a negative. So you can always kind of check yourself if you're not sure about your signs, especially when they give you a graph. Questions about example 2? Okay. On we go. Now these ones, they don't give us a graph, so we cannot count our rise and our run. We could graph it ourselves and then count it, but we know an even easier way, which is to use our formula. So once again, the goal here is always to write y equals mx plus b, but to replace the m and the b. So in order to do this problem, I need to know what m equals and what b equals. That's my goal. On this one, it's actually easiest to identify the b first. What is it? Good. Remember, your y-intercept happens when x is 0. So that makes this our b. You have questions about that? If x is 0, that means that's the y-intercept. Okay, then we have a little bit of work to do to find the slope because we have to use our formula. So remember, we have to use y2 minus y1 over x2 minus x1. Okay. 9 minus negative 6 over 3 minus 0. Subtracting a negative means I'm really adding that 6. 9 plus 6 is 15. 3 minus 0. So that reduces to be what? 5 over 1, or you can just write it as a 5. I'm okay either way. Holding on. Okay. Yes, you can put it over 1 if you prefer it that way. Doesn't matter to me with that one. So when we go to write our equation, we've got m and b, so we must be ready. Very good. Y equals 5x minus 6 would be our equation. All right, when we start that second one, again, my goal is to know m and b. Which one do we know right away?
B, the y-intercept.
Good, the y-intercept is 2, because we see that point that has 0 for x. So that must be our y-intercept. To find our slope, m equals 2 minus negative 1 over. Good. Subtracting a negative means I'm really adding. 3 over negative 4 is my slope. You can put the negative out in front, up and top. Technically, it's okay if it's in the bottom. That's just the least common way. Good. Y equals negative 3/4 x plus 2 is what we get when we plug our m and b in to write the equation. In that box down at the bottom, we talk more about functions. If f is a function and x is in its domain, then f of x represents the output of f corresponding to the input of x. Now, that's all very wordy. Our example is f of x, the function of x, equals 3x minus 4. We are asked to find f of negative 1. So what does this mean they want us to do? They gave us an x. What x value did they give us? -1. So instead of putting an x, they put a -1. So instead of putting an x in the equation, they want us to put a -1. So remember, this notation is just a little bit different from what we're used to. So f of -1 means we're plugging -1 into x. Why am I putting parentheses there? Because we're multiplying. So I want to make sure I remember to do that. It's not just creating a new number. It's not going to end up meaning subtraction. We are multiplying 3 times -1, which is -3 minus 4, -7. So down at the bottom of that box, it says we can write this point. So remember, your points are x comma y, or input comma output. So what was our input? What did we plug in? -1. What did we get as our output? -7. So just reviewing some of that function notation. Questions, concerns, need more time in our functions box. So the next one asks us to write the linear function f with these values. Now, so far when we've been doing slope-intercept form, we've been writing it as y equals mx plus b. Y equals mx plus b. But another name for y would be to use f of x. And we could still write it as mx plus b. So really, these problems are going to be very similar as far as the answer goes. The only difference is that we are going to have an f of x instead of a y. Other than that, our answers are going to look the same. They also require us to do a little bit of an extra step at the beginning of the problem compared to the ones we saw in the last examples. Okay, so these problems are extraordinarily similar, just a little different with the f of x notation. So, they gave us that f of 0 is equal to -4 and f of 3 is equal to 8. From that, we need to understand that that represents two different points to us. In the first f that they gave us, f of 0 equals -4. What do you think they plugged in for x? The 0. They put 0 in place of the x. And what did they get as their output? -4. So the second function value they gave us represents what point? 3 comma 8. Questions about how we're getting this information from what they gave us? Okay, after we pull that information out, then this problem is just like the examples from that section before the functions box. We've got 2 points. We need to know m and b. Which one do we have already? B is -4. To find my m, I have to use my slope formula. 8 minus -4 over 3 minus 0. Subtracting a negative means we add it. 12 over 3 reduces to be 4. You could put 4 over 1 or just 4. So when we write our answer, we need to write it, instead of a y, an f of x. Good, for x minus 4. Now, if this were on a test or a quiz or something, and you wrote your answer with a y, instead of an f of x, I'm not going to take off points for that. We should try to keep our notation consistent with the problem. But if your only mistake is that you wrote a y here instead of f of x, then clearly you still know what you're doing. So I'm still going to give you your points. Okay. Questions, concerns? Okay. So on letter B, why don't you go ahead and give that one a try on your own for a minute. Remember, you're going to have to identify what points they're using. And then identify your M and your B so you can write your function. All right, on letter B, we should have come up with the points 0, 10,
634.
and 634. Good, that means our B or our y-intercept is 10 because that's the point that had 0 for x. We find our slope by taking over. Okay, what do we get from that? Reduces to B. 4 or 4 over 1. So we write our function f of x equals, ladies, 4x plus 10. Good. Questions, concerns about number 4? A or B?
Now, can I do the next one?
The next one. Sure, Jaysha, talk me through the next one.
Okay. So 0, 2,
Good.
2, 4.
Okay, we got our points.
Y-intercept is 2.
We got our B.
4 minus 2. 2 minus 0. 2 over 2 equals 9.
Good, so we find our slope by taking 4 minus 2 over 2 minus 0. Simplify, we get a slope of 1. So Jaysha, what is my function? Good, 1x plus 2. If you just write it as x plus 2, that is also acceptable. Either of those would be great. Questions about letter C? Question?
No, it's not a question.
Okay. Any new volunteers to walk me through letter D? Lydia? Okay. Good. Y-intercept of negative 4. Good. 0. 0 what to?
0 minus 2. No.
Minus a negative 2. Okay.
10 over 2.
Careful. The 10 would be
Negative 10 over 2.
good. Negative 10 over 2. We end up adding there. So my slope is a negative 5.
So 5 equal negative 5x plus, subtract 4.
Very good. So f of x equals negative 5x minus 4. You could always double check yourself by plugging back in the x values that they give you and seeing if you get the same y value out. So if we plug a 0 into this function, 0 minus 4 would give us negative 4. If we plug in a negative 2 here, negative 5 times negative 2. What's negative 5 times negative 2? 10, and 10 minus 4 is 6. So that's what they said we should get. So you can always double check your functions by plugging the x's back in. So if you ever want to know if you're right, you can check yourself. Questions on letters C and D. All right, moving right along. Our last little note box in here. A linear model is a linear function that models a real life situation. We are able to use this, the idea of y equals mx plus b, when a quantity y changes at a constant rate with respect to x. So something that changes at a constant rate. Oftentimes this will be things that involve money, because you get paid a certain wage per hour, so it's changing at the same rate with every hour. It could be something that deals with time, like you're traveling at 50 miles per hour, so as long as you're not changing your speed, you're going 50 miles for every 1 hour. Okay, things with a constant rate of change. Questions or need more time on this slide? Okay, we'll get into our real life applications. In 2000, the average cost for college tuition in the U.S. was about $14,000. 2010, the cost was about $18,000. Write a linear model that represents the cost of tuition as a function of the number of years since 2000. Use the model to predict the cost in 2020. So there are a couple things that are going on here, and it'll be helpful for us to identify our independent and dependent variables. So let's talk about them. What do you think is independent here? Ooh. So it'll be our x that's independent, but we're dealing with two things. We're dealing with time, and we're dealing with tuition cost. Time is always going to be independent. Time doesn't depend on anything. It just keeps going. So our independent variable is going to be years since when? When are we starting this? Since when? 2000. Years since 2000. And we said which letter variable represents that? X. Okay, we should also identify our dependent variable. Ooh, that got sloppy. Dependent variable, which is probably easier to identify now. What is it? Our tuition cost. And what letter will represent that? Y. I would stick with X and Y. You can change them up, but in this case, I think it's going to be easiest if we use X and Y. So they gave us a lot of information here, and the information they gave us, we should try to represent with points. So they said in 2000. That means how many years had passed since 2000? In the year 2000?
No.
0. No time had passed yet. So if I'm representing this sentence as a point, I put a 0 in for my time or my x. I'm going to have to space that out a little better. So in 2000, the average cost of tuition was?
0.
No, that was our time. In 2000?
14,000.
Was 14,000. We got to be able to read our problem to see our information here. Questions about how we came up with that point? Okay. In 2010, so now how much time has passed? 10 years. The tuition was? 18,000. So we are going to use those 2 points to write our model. If it says write a linear model, that means write a linear equation. So we need to identify 2 things. What do we need to identify? M and B. Same 2 things we've needed all along. Again, our B is pretty easy. What is it? 14,000. To find my M, I need to use my slope formula. What's going in the top of it? 18,000 minus 14,000 over 10 minus 0. Okay, when we subtract those, what do we get? What over 10? I just couldn't hear. 4,000 over 10. Which 4,000 divided by 10 ends up being 400. You can just cross off 1 0 on each of them. So our M is 400. Okay, so our linear model is going to be what? We can use a Y. It's okay to use a Y here. Y equals 400x plus 14,000. Okay, so that is our linear model. If we are using that to predict the cost, which letter are we looking for if we're looking for cost or tuition? Y. We're trying to find Y in 2020. In 2020, what is our time that's passed going to be? 20 years. So we're finding Y when X is 20. So that means we have to plug what in for X? The 20. Okay, so 400 times 20 is 8,000. Take the 4 times the 2, add all your zeros on there. 1, 2, 3 zeros. And then we add the 14,000. We would get 22,000. So we would estimate that the average cost for tuition in 2020 is going to be $22,000 per year.